Hello, welcome to my channel. I am Amaya. In previous video, we talked about why and how 3D manipulation is important in 3D environments. In this video, we will be talking about canonical tasks in 3D manipulation and some application specific tasks. In 3D interaction, canonical manipulation tasks like selection, positioning, rotation, and scaling are essential for interacting with virtual objects. These tasks are defined by specific parameters that affects how precisely user can perform actions in the virtual environment. First, let us talk about selection. Selection involves identifying or acquiring an object, and its accuracy depends on the factors like distance to the target size, target occlusion. For an instance, selecting a small component in a cluttered virtual car model requires precise targeting to avoid selecting the wrong component. Positioning is the task of moving an object within virtual space. This task depends on parameters such as distance and direction between the object's initial position and target position. In industries like automotive design, precision is the key. Moving a car part by just a few millimeters can have major impact on the design. Third is the rotation. Rotation changes the object's orientation. Here, the parameters include amount of rotation needed and the precision required to match the final orientation. For example, rotating an engine in a VR prototype needs to be exact to ensure proper component adjustment and alignment. Finally, scaling adjusts the object size. The scaling task depends on initial and final scale along with the precision required to make sure the object fits well within the surrounding. In VR design, scaling allows engineer to zoom in for the detailed inspections for the vehicle's component without losing sight of the bigger picture. These canonical tasks and their parameters are crucial for achieving accuracy and efficiency in VR manipulation, where even slight miscalculations can lead to costly design errors. While canonical tasks provide a groundwork for 3D manipulation, they aren't enough in a specialized field that require unique interaction methods. These application-specific manipulation tasks adapt to the particular needs of the industry or a scenario. Take an example of medical VR. In virtual training environment, a doctor might need to guide a probe inside a virtual human body model. Here, positioning and selection are not straightforward due to integrate movements required. VR systems adapt by introducing customized manipulation technique that allow for ultra-precise control, replicating the delicate nature of real-life surgeries. In the world of automotive design, the need of specialized manipulation is also clear. The designer working on a car's door in VR might not just need to move it into place, but also simulate how it feels in real life, factors like weight, friction, resistance while moving that door. These parameters are not covered by simple canonical tasks like positioning or scaling, but through customized manipulation model that take into account this specific requirement of task at hand. Such application-specific task shows the flexibility of VR system, pushing beyond general interactions to meet the demands of highly precise work environments. This is all about the canonical tasks in 3D manipulation and application-specific tasks. If you like this content, do subscribe to my channel and keep following this video series for more videos related to ARVR in automobiles. Thank you for joining.